I believe you can see, what you see here is the human brain. So the human brain has two sides, the left lobe and the right lobe, and it's exactly identical. They are like mirror images of each other. So what I'm showing you is a section through the brain. It's being cut right through the middle, front to back. And there's something important that I want to talk about this brain. So the two areas I have highlighted are one is called the frontal cortex, or we can call it the prefrontal cortex, which is the area that is circled red. You see how much of the brain it takes? It's almost most of the brain. And then the second one is called the amygdala, which is this tiny little thing over there. And the amygdala is named after acorn. So amygdala is not acorn, almond is the word for almond in Greek. And if you look at this picture where my pointer is, that is an almond, and comparing it to the size of a capsule. Many of us have taken medicine. So that is the size of the almond compared to a capsule. And so that's the size of your amygdala is as small as a tablet and a capsule that you would take if you are feeling unwell. Now, these two parts of the brain are the parts of the brain that control the way we as human beings react to external stimulus. When there's a stimulus from outside, someone says something to us, or we hear about something, or we see something, those are the parts of the brain that determine how we are going to react. Now, for those who have not heard about this concept, this is going to be a little bit of news. So this part of the brain called the frontal cortex is the one that as a human being, you want to be functioning all the time. But newsflash, this part of the brain is not mature until your mid to late 20s. It starts undergoing development when you're born, and then when you reach about the age of 11 years, rapid changes begin to happen in it. And it continues non-stop until your mid-20s, and for some people up to their late 20s. What does it mean? The frontal cortex, as you can see, is concerned with planning, thinking about consequences of your actions. It is concerned with solving problems. When a problem comes to you, how do you solve it? A math problem, a life problem. And then it's also concerned with controlling your impulses. If someone says something to you, how do you respond? Are you going to fight immediately? When you see a car on the road, are you going to run away immediately, or are you going to judge how far the car is going to decide whether you can cross or have to go backwards? So when all that is happening, it is the frontal cortex that is supposed to do that. Now, unfortunately for young people, from the age of 11, like I said, to your mid-20s or even late 20s, this part of your brain is not yet doing those functions to capacity. It is still developing. Now, so what is controlling a young person's mind? The young person's mind is being controlled by the almond, the amygdala. It controls your emotions, and that is why you see a lot of young people are moody. Very often, they swing between being moody and excited. Someone can come from yeah at a party, and the next minute she's crying, or he's crying, or he's sad, doesn't want to talk to anyone. It's because of that little almond in your brain. It controls our impulses. You've noticed how young people very easily get into a fight. How did you say that about me? How do you call my mom that? You know, how can you say that? And they jump into a fight. Aggression, instinctive behavior. So, in other words, the mind of a young person is exactly like the mind of an animal. This part of the brain is actually called the primitive brain. Its function is for one, to help an animal move out of its parent's care to establish itself. In other words, it should be ready to take risks, to start a family. You've seen how young people are always having crushes on different people, getting into relationships. It's because that part of your brain is actually what is pushing you to get there. So it's an animal instinct. You're trying to establish yourself, to start a family. You're ready to fight off enemies, and that is the aggressiveness. Impulses, you're ready to run away when you think there's danger, or you're very quickly, or you freeze. You know, you either run, freeze, or get into a fight. So that is what is happening in the brain of a young person. The control is being done by the amygdala. Now, so the question is then, what exactly is happening in the prefrontal cortex, that part of your brain that you really need to help you make rational decisions, think about consequences, plan your life? There's a concept that is called use it or lose it. I don't know if some of you have heard about it. Has anyone heard about that concept? Use it or lose it, concerning the brain. Anyone? Unmute yourself if you have. Okay, the silence makes me assume no one has heard it. Now, so as someone is developing, as a young person is developing from birth, something happens in the brain. A lot of what we call neural networks are established. They're like electric wires, right? As the person is being exposed to the world, is seeing a lot of things, learning a lot of skills, it's like electric wires begin to create all over the place and join. And if you look at the picture in the middle, you know, at birth, you can see the connections are very few. The only thing the child has had is the heartbeat of the mother, maybe some sounds from outside. So really, there are very few connections. But when the child is born, by the time it is 6 years, we almost have reached the peak of, we've reached the peak of neural network development. There are lots of electric cables in there. The nerves, by the way, are like electric cables. A lot have been formed, and there are so much. And if you look at a child around the age of 6, 7, 8, 9, they can be irrational. They are taking risks, they are crying, they are fighting, they are playing. They are really doing so many things. They are willing to learn new games. They are really willing to learn how to swim, to do all sorts of things. It's because the brain is developing, it's learning so much. It's a stage when people learn a lot. And when children, for instance, in that age group, learn a new language, they will learn the language with the accent, the correct accent of that language. While if someone like me decided to learn, for instance, French now, if I spoke French, it would have a lot of my actually accent within it, because my brain has finished developing these neural networks. Now you look at the brain of a child that is 14 years old. What do you notice? Can someone tell us what you notice? What's happened? Vivian, what do you notice? Look at the picture of the nerve connections in the brain of a 14-year-old and compare it to that of a 6-year-old. What do you see? Any volunteer? Tracy? Tracy, do you notice anything different?
It's well structured and it's more clear.
Okay. Okay, I like the way Chrissy has put it. It's more structured and it's more clear. And that's exactly what begins to happen from the age of 11, a process that is called pruning. And those who are familiar with gardening, when you have a plant that is growing, we prune, we cut off some of the branches that are tiny, the small branches that we think have no potential. They are tiny, they have no potential, and they're just crowding out those branches that are more important. So we prune those off. And so that's exactly what happens in your brain. From the age of 11 to your mid to late 20s, your brain, there's a set of cells that begin to prune the excess nerves in your brain. And you may ask me, how does this cell decide what it should prune and what it shouldn't prune? These cells are sent with instructions: prune all the connections that are not being used frequently. And so these cells are going to go in there, and whatever connections are not being used frequently, they're going to prune. They'll just cut them off and chop them off, whether they are actually important or not. Their instruction is, if it's not being used frequently, just chop it off. And so by the time you reach your mid to late 20s, the permanent connections have been established. They've removed all that is considered excess. What you're not using is lost. In other words, use it or lose it. And then after that happens, there's a process that we call myelination. So for those who may have forgotten their biology, so this process is like insulating electric cables. So when you look at the electric cables around your home or even in your house, they are all insulated. They have an insulator. So apart from the fact that it protects you from electric shock, it's also important it helps to increase the efficiency of the cable. So it is properly insulated, electricity is not lost all over the place, and electricity moves from point A to point B without a lot of disturbance. So that is exactly what happens in the brain. You may be asking me, how relevant is this to what we're discussing, but I'm going to show you as we go along. Now, this is a short video, and I want you to listen very carefully. It really reiterates what I've been saying. So make sure your microphones are on. Okay.